Hey everyone, I'm Song Wang from York University. Today I will be presenting our study, Automatic Unit Test Generation for Machine Learning Library. How far are we? And this paper is done in a collaboration with Nashita Abana and Moshe from York University, Canada, and also Jun Jie from Chinese Academic Science, and Nash from Facebook. All right. And at the very beginning, let's first have a quickly overview of the general process of test case generation tools. So given a program, a test generator usually will first explore the input space and produce the test cases. And among the generated test cases, some test cases may be failed, which will be further checked for finding potential bugs. So over the last few decades, researchers have made many advancements to solve the unit test generation problems. And many unit test generation tools have been proposed. And also they have been examined, are very useful to generate the test cases. However, the fact that those existing test generation tools are mainly evaluated on general software program motivates us to ask the question, so do the automatic unit test generation techniques work for machine learning libraries? So different from general software projects, usually machine learning libraries can be decomposed into three different components. They are data process, core model, and util. Specifically, data process usually contains the classes that are used to pre-process data. For example, data format transformation, data sampling, data normalization, noise data filter, and the core model usually contains classes that implement the core machine learning algorithms. For example, classification, regression, clustering, and the util usually contains classes that provide a service for evaluating the models, measuring the performance, and even internationalization. So in this study, we selected five Java-based widely used machine learning libraries. They are Weka and Stanford Core NLP. Those two are academic leader, which means the core contributor researchers. And we also select the three open source community leader projects. They are Mallet, Apache OpenLP, and Apache Mahout. All those three projects are widely used Java-based open source machine learning libraries. Regarding the test case generation tools, we focus on two types of typical and scalable approach based on search-based optimization of call sequence, that is EVOSUITE, and the random generation of call sequence, that is Randoop. To measure the quality of the general test cases, we adopted two metrics. They are coverage and mutation score. And for the mutation score, we applied PyTest to generate mutants and measure the score. In this paper, we try to answer the following three research questions. The first one is about the effectiveness of a test generation tool. We intended to explore the effectiveness of the two automatic unit test generation tools in machine learning libraries. And in the second research question, we try to understand the testing focus of those machine learning libraries. That is, we want to understand which part has not been covered, has not been tested with the original test suite in the machine learning library. And in the last research question, we try to understand the improvement of the unit tests generated by the tools compared to the original test suite. All right, to answer the first research question, we have run Randoop and EVOSUITE to generate the test cases for each category on the five machine learning library. And after we generate test cases, we further collect the coverage information and also the mutation score. So the table here will show the coverage information. We show the number of generated test cases, absolute coverage, and the additional coverage compared to original test cases. And we can see from the table overall, both Randoop and EVOSUITE can have achieve a higher coverage compared to the original test cases. However, we can also find that the improvement on some component are limited. For example, on the weaker the core model, the improvement is only 1%. On core NLP util, the improvement only 1%. Okay. So we can say that both EVOSUITE and Randoop lead to clear improvement in code coverage and mutation score. However, the improvement is limited, and on average, there's still a large portion of code still uncovered. All right. In the second research question, we try to understand which part of machine learning library has not been tested with the original unit test suite provided by those machine learning libraries. So what we do here is we randomly selected 10 classes from each category of each machine learning library. In total, we have 150 classes. And the first three authors work together to manually categorize the uncovered code into the 5 different types that are lack of testing valid behavior, lack of testing message handling behavior, and invalid behavior, exceptions, and auxiliary method. And the numbers here shows the percentage of each category. We can find that overall, most of the uncovered code belong to auxiliary methods. So overall, we can find that the original unit test suite in machine learning libraries mainly only focus on the subset of validated functionalities, and there exist common patterns among the uncovered code. All right, for the last research question, we want to understand how the unit text generated by Randoop and the EVOSUITE improve the coverage. So what we do here is we conduct a further analysis to explore which part of source code can be covered by using the test suite generated by Randoop and EVOSUITE. On the 150 classes collected in RQ2. So from the table, we can see that overall test cases generated by Randoop and EVOSUITE can help cover more uncovered code block on each of the 5 categories compared to the original test cases. However, we can also find that the improvement on different categories are significantly different. For example, on the last two, that is auxiliary method and message handling behavior, the improvement are significantly better than other 3. So, for example, on the IVB, on Mallet and OpenLP, the improvement on Randoop are 0, right? Okay, so we can say that both EVOSUITE and Randoop can help reduce a large portion of uncovered code for the 5 different categories, while the performance on some category is limited. Okay, to summarize, in this paper, we conducted the first study to investigate the effectiveness of existing unit test generation on machine learning libraries, and our results confirm that unit test case generation tools, for example, Randoop and EVOSUITE, can lead to clear improvement compared to the original test case regarding the coverage and the mutation score. However, the improvement is limited, and there do exist common patterns that we can use to further improve the test case generation for machine learning libraries. All right, thanks for listening. Now, this is our talk.
Hi, everyone. Welcome back to this Q&A session. We are now going to discuss the paper titled Automatic Unit Test Generation for Machine Learning Libraries. How far are we? we have the pleasure to have Song Wang from York University in Canada here with us, and he'll be happy to answer your questions. So thank you very much for being here. Let's start with the first question by Rashmi. What is your metric that determines the lack of testing? For instance, is it the number of lines not covered in that category?
All right, thank you for the excellent question. Here, yes, we do use a line not covered to measure how many, for example, lack of testing, valid or invalid behavior. What we do here is we randomly collect a bunch of classes and run the tools to see how many lines were covered, how many lines were cannot cover by using test case generated by those tools. And then we do a manual analysis. We manually check each line of the code that cannot be covered and then categorize the code into one of the 5 categories.
Okay, and perhaps the question that follows up exactly there is, how do you decide that these 5 categories are enough, or how do you decide that these are your 5 categories?
All right, that's a good question. So if you look at the code uncovered, you may find that it's pretty clear. Some of the uncovered code are from for example, the core algorithm. You can definitely find, okay, this is the valid behavior of algorithm. Let's say the parameter, they have many different optional values and only cover 1 or 2. They left many other possible parameter value uncovered. So this is a kind of valid behavior. There's a lot of very straightforward hints that we can use to summarize the categories. So in total, we have 5. One is the valid behavior. From basically, if any line missed in the code function, we categorize it to the valid behavior. And also, there's a exception, lack of testing exception is pretty obviously. We check all the catch and try block. If you cannot cover, then that is lack of testing exception.
Great, thank you very much.
Yeah.
There's another question by Andre. Could you elaborate a bit more on how you have computed the mutation score for this project?
Oh, we use the PyTest. There's a widely used tool to calculate the mutation score. And also we use the default mutation operator. I think if you try different mutation operator, you may have different score. The reason why we use the default mutation operation is because it really takes too much time if we use all the mutation operator.
Thank you very much. We have a question from Caroline Brandt. She says, thanks for your talk. Could you or did you try to contribute some of the generated test cases back to the project? Did you inspect the generated tests in more details? What was your experience on the understandability?
Oh, that's a very excellent question. Actually, if you have experience in test case generation by using either EVOSUITE or Randoop, those are 2 different types of test case generation, you will find that the generated test cases have a low readability because the variable name was randomly generated. Even the method called chain was randomly generated. We try to understand, but cannot match a real world scenario. However, we do check some test cases, and we found several bugs reported by those test cases. Those are not readable, but they do can find bugs.
We have a question from Chanduk. What are the main challenges in automated unit test generation for machine learning libraries?
Thanks for the good question. I think the main challenge here is first of all, there's a challenge in the Oracle issues. This is the general challenge for whatever test case generation. For machine learning library, the unique challenge here is that we need to cover all the parameters. We need to generate data, not only function called chain. For example, for a general project, we only generate a method called chain. That's enough. But for machine learning libraries, it's data driven. You also need to generate data. I think that's the main challenge. Thanks.
Thank you very much. While we wait for more questions to come, may I follow up on that particular last point that you mentioned? So it's relatively well known that tools like Randoop and EVOSUITE struggle precisely in what you just said, generating complex data structures, right? So what makes you choose these two particular tools, and why, for example, would you not use CLI, that is a symbolic execution tool that could potentially produce richer results in some particular critical cases?
As one of the reasons we didn't use the symbolic execution based tool is because the time and cost, scalable issues. Before we choose Randoop and EVOSUITE, have been searched a lot on the literature research. We try to find a tool that can be useful. At the very beginning, we target at a Python project. For example, TensorFlow, CNTK, all those libraries are in Python, but unfortunately, there's no test generation tool for Python. That's our ongoing work. So we switched to Java machine learning libraries, and also EVOSUITE and Randoop are the two widely used test case generation for Java project.
Okay, thank you very much. There is a question from Eric Fredericks. Hi, Eric. Apologies if this was already asked. It hasn't been asked, actually. Are there any considerations on how test oracles are handled for automated unit tests for ML?
That's a very tough question, actually very good. Because text oracle, I think our current research cannot solve it. Oracle issues. It's even more difficult than general software. For example, general software, the output only a string or integer, but machine learning maybe output an array or a list of data. It's going to be very difficult. Because currently we don't have a very strong test oracle. What we did is we still call the function call even a function. If the general test case do not crash, we think it's a good test cases. If it crash, we're gonna further check whether we find bugs or it's a false positive.
Thank you very much.
Thank you.
Having a little bit of experience developing EVOSUITE, I have to ask whether, from your experience running this experiment, it would be a matter of tweaking EVOSUITE or extending EVOSUITE a little bit, perhaps to make it more successful with its libraries, or do you think that an entirely different and fundamentally different approach could be needed?
One of my students is currently trying to modify EVOSUITE for testing machine learning library. But I think what we can do here is we can cover a little bit of valid behavior by mining the API documentation. For example, we can see which parameters, what are the range of parameters. By using those methods, when we generate test cases, we can give it a little bit of guidance to generate a test cases cover more valid behavior. That's what we can do. Another big challenge is still the data-driven issues. EVOSUITE cannot generate a so large data set, so we have to find a new solution.
One solution is to use the approach that Ezequiel presented earlier, where you have this probabilistic grammar-based test generation. Well, thank you very much, Tom. Very nice work, very nice presentation. Thanks for all the answers. And if there are more questions from the audience, please feel free to follow Song to the discussion room for his paper, where I'm pretty sure that he will be very happy to take any more questions.
All right, thank you. Feel free to let me know if you have any more questions.
Yes, thanks. Our next paper is titled Using Relative Lines of Code to Guide Automated Test Generation for Python. It's a very nice paper that was published in TOSEM last year. And the presentation is going to start in 5 seconds. Thank you all very much, and I'll see you in 10 minutes.
Thank you.